Yep. All right. You know these things, right? Minimum. Those are very important for us. Product. Yep. Some. Yep. These are column wise. Column wise. Yep. Okay. And the other one is element wise operations. No. So let's say, let's clear my screen. Okay. And v is a vector. Let's define a vector, right? Row vector 1 2 3. So I don't want to see the output. All right, so now I'm going to compute sine of this vector. If you type in this way, you will get the sine of this element, sine of the second element, sine of that one. This is the convenient use in matrices. This is the convenient use in octave row. Yep. You don't need to type sine of 1, sine of 2, sine of 3. It comes straight away, right? So this is the, yeah, here look at this. If you define a row vector like this, then if you type exponential of this vector, it gives you this value here. You don't need to type one by one like this. Just type exponential of the entire row or entire matrix. Say, let's find sine of the matrix A. Matrix A. We had A. Let's see what. Let's read the matrix A. This is our matrix A. Then find the sine of each element. Sine of each element. If you want to compute sine of each element, just type sine of the entire matrix. That's it. Right? The octave will do the job, right? So you don't need to type sine of 1, sine of 2, sine of 3. But if you type sine of the matrix name, so it will, the octave computes the sine of each element like this, right? So this is the element wise operation, right? All the functions that work on scale also work on vectors. Okay. Okay, and division. Yep. All right, let's see this one here, right? Let's say, okay, let's clear this one. Clear the screen. And we had vector v, right? V is this one. Okay. So let's say I want to find the square of the each element. So how do you find that? V squared. If you type in this way, so V squared, right? So that means V squared. I want to see 1 squared, 2 squared, 3 squared. But if so, this is the we are doing the element wise operation. So if you type in this way, this gives you an error, right? But if you type with a dot in front of this operation, you can do, yeah, doubling these elements here. So, yeah. So if you type in this way, this means do the element wise, square the element wise, yep, right? 1 squared, 2 squared, 3 squared. because these are vectors, right? So put the dot in front of the operator, right? If you want to do element wise operation, put a dot in front of the operator, right? So I think you know we are refreshing our memory, right? Yeah, yeah, yeah. Still refreshing our memory. Okay. So here, yep. So this is a row vector. This is a column vector. If you type in this way, get an error message. But you have to transform this one. When you transform transpose, when you take the transpose of the row vector, then it will become a column vector. No, this is a column vector. When you transpose P, then it becomes a row vector. Then you can use this one. You can compute the element wise operation, right? Those are simple thing. I think you know, right? What else? Operations, yep. All these things, yep. So you can initiate, yeah, initialize, yep. Yeah, let's clear the screen. So you can initialize, say, so you want to, yeah, let's define another matrix, say C. I want to fill this matrix with ones or zeros, right? C is a 3 by 3 matrix with all zeros. How do you do that? There's a built-in function to do that, zeros, and put the dimension. You can put either this one. This means a square matrix, the dimension is 3. This is a square matrix. The dimension is 3. The number of rows and columns are the same. So if you put this one, then C would be a 3 by 3 matrix with so all zeros, yep. Right? Or you can do like this if you like, yep. I think, yep, number of rows 3, number of columns 3 in this way. Or if it is not a square matrix, can change, yep, the dimension as you want, right? If the dimension, that means number of rows and columns or square matrix, then you just need to enter a single value, the number of row or column, if it is a square, right? So this is not a square matrix, right? So similarly, yep. So if you type once, you can fill with ones here, ones, or zeros, ones, what else? Zeros, ones, random, yep. So if you want to generate a matrix, its dimension is 3 by 4 with random numbers. How do you random? Let's say random. So this will be a matrix, and the dimension is what is the dimension? 3 rows, 3 columns with random numbers. Yep. 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 This one. Yep. Something like this. Sky, yep. Yep. So any questions? I didn't know these things. Yeah, fetching out, am I right? Any questions? Any doubts? Any questions you have? And this one is none. Yep. None. What does it mean, none? So it's also, yep, here. Not a number. Yep, you can fill with that as well. Something uninitialized variable. So okay. Okay, so let's jump into this one. This one is very useful when you plot a graph, right? So linspace, what you do here, you discretize. So this one start from 0 and end at 10, and the increment is 5 here. Yep. So starting from 0 to 10, this one, this one goes with an increment of 5. Yeah, increment by 5. Yep. Let's this one is very useful. So you have an experience. Yeah, you have experience to use that. So let's clear my screen, CLC, by typing CLC. Okay. Yep. So linspace. Yep. Let's define a vector. Let's discretize the time. Time t is denoted by time. Let's say time, right? So I want to discretize, so this is 0-1 interval, right? So yeah, let's go. This is the starting point, this one is the end point, and this is the increment. All right. I have to get familiar. Linspace. All right. Starting point. I said 0 is the starting point, 1 is the end point, and the increment. Let's increase this increment by 0.1. So this gives you, so this is your interval 0, 1. So I split this interval into sub-intervals. The length of each sub-interval is 0.1. All right. So why is this? Linspace. Okay, why linspace? Why I'm getting? Let me check that one. This way. What is the reason? I'm not sure. Is the increment? Yeah, yes. No, should be the number of values. Shani, thank you. We should use, yes. Every day I should use. Let's see. How do you do this? Yeah. Linspace. I think I did correct. Linspace. Yeah. It's not working yet. Let's say linspace. Let's take a simple one, right? Space from 0 to 10. All right. And the increment. This is the increment by 2. So what's wrong with this? Deshani, can you help me with this? So I will give you permission.
This you should put the last number as the number of points you want to take. It's not the increments.
All right. Okay, thank you. All right. Number of points. Okay, then I want to, that means number of points. Okay. I want to break this one. Right. Number of 10 points. That means we have 9 subintervals. Okay. All right. Thank you, Deshan. All right. Okay. So this is the initial starting point. This is the end point, and this is the number of points you have to include in between 0 and 10. Right? Not the increment. Yeah. Not the increment values by values. Okay. Right. Yeah. All right. Yeah. So, all right, guys. All right, let's discretize. Yes, 0, 1, starting from 0, and this goes to 1, and the number of points. You have to include number of points, or number of points you have to discretize. So I'm going to discretize 0, 1 interval into 10, or 5, into 4 subintervals. That means 5 points. So you include 5 points in between 0, 1. Right. That's right. That's clear. 1, 2, 3, 4. 4 subintervals, but it has 1, 2, 3, 4, 5 points in between 0 and 5. All right. Okay, guys. Thank you, Deshan. Right. This one is very useful. And there's another command here, this one here. A similar command, right? This is the starting point and end point, and this one is the increment starting point. It's a cool, I think it is a coulomb. X is starting point, and the increment, let's say increment is 2.25, and the endpoint is 1. Same thing. So this is the increment, and this is the starting point, and this is the endpoint. So you can use either of these two, right? You can use linspace or this one. So the length of the subinterval is this one, and this is the left end of the interval, this is the right end of the interval, big interval. You split this interval into 1, 2, 3, 4 subintervals. Each subintervals, the length of each subinterval is this much, right? So that's the thing. I think this makes sense. This is the point, number of point. So this is the starting point, end point, and the number of points you have to include in between these 2 points, between these 2 numbers. All right. I have to remember that. Yeah, that one is very useful when it comes to plotting a graph, right? Yep, matrix indexing. Yep, we have discussed that. This one, yep, and the other one, yep, yeah, we have discussed the maximum minimum. How do you get a maximum minimum, right? And you had to spot the position. So let's try to spot the position, right? Let's where the maximum occurs. That is very useful when you do programming or when you coding. Yeah, let's clear this. All right, so let's enter a vector 1 5 2 0, right? Vector, right? Or matrix, anything you can say, right? It has only one row and many columns, 1 2 3 4 6 columns. Now I want to find the, yeah, let's say, so let's find the minimum value of minimum element of this vector. How do you find that? Now I use a built-in function called min, right? So let's type this out. Yep. Okay, minimum element is this one. Now I would like to see the position. I want to know this minimum value is where the, I want to spot the place. I want to spot the location of this minimum value. So how do you find that? So that's why I use this find built-in function. Yeah. So let's find the index, or let's put the location of the minimum element of this vector. So how do you do it? Yep. So let's find. So we use find command. So you have to give the vector or matrix name. What is the name? V. Yeah. V should be equal to the minimum value of, we have minimum value of V. Yep. So we can spot the place. So let's see. All right, it is, yeah, it says it is located, the minimum value is located at this position, fourth position, 2 3 4. Yeah, this one is very useful, right? When you do so minimum, find the minimum value of a matrix. So because you are playing with matrices, when you do something on Octave or MATLAB, you are playing with matrices. That's why you learn matrices last semester. So everything about matrices, you have to play with matrices all the time. All right. All right. The position is this is the position 1 2 3 4. Yeah. So by using find command, you can spot the position, right? Spot the position of the minimum of minimum element of this vector. All right. So that is very useful, right? And linspace. Yep. Let's try to plot a graph. Yep. Let's try to plot a graph. Yep. Let's. I go to edit here, editor, right? So by clicking, yeah, I think you know, right? This, yeah. All right, let's try to plot a graph of sine or something, cosine function. Yeah. So first of all, you have to discretize your variable independent. Let's take x is our independent variable, right? So I want to plot a graph of sine. Yeah. I will define the domain. I will discretize the domain. I'm interested in minus pi plus pi. Yep, that interval. So I discretize minus pi, yeah, that interval into small. Yeah, I split that interval into small sub intervals. You know these things, right? If you need a smooth curve, you had to discretize, you had to split a lot of sub intervals, right? Let's do that using linspace. Don't know. Yep. Yeah, let's discretize linspace. Starting point, yeah, minus pi, and the end point plus pi, and the number of points. Remember, number of points are I want to include in between minus pi and plus pi. Oh, it is confusing here. 50, let's say 50. I want to include 50 points. Okay. Yeah, discretize. I don't want to see the output. That's why I include the semicolon at the end. So can you see these letters? I'm recording this one. I'm not sure whether you can see these. These are very quite small. Oh, you can see these letters, right? Okay, so I discretized the interval minus pi plus pi. I included how many points? 50 points in between minus pi plus 5. Then, all right, now I define my dependent variable, something like sine. Yep, there's a built-in function sine. You know, there's sine of x. All right, so this is my dependent variable. Now I put sine of x or y versus x. Yep. Using this, I think you know the command, right? Plot x coordinate, comma, x coordinate, comma. So here, look at this here. So this is you get an array of numbers here. So how many points do you get? You get 50 points. You have 50 points. This is a vector, right? This is a matrix. X is a matrix. It contains, I think, 50 elements. It has only one row and 50 columns. Yeah, 1 by 50. Let's check the size. Yeah, later we can check. Yeah. So this is a 1 by 50 matrix. So now you use, so here this one is a matrix X. So then you can find the sign of that matrix. That means you operate element wise. You compute sign of each element in this matrix, right? All right. Now I print each x and the corresponding y value. So x and the corresponding y values. Yeah, y. All right. So let's, if you want to run this code, you have to, hit this button. Before that, you have to save, you have to save, give a name, I will put one, right? Save, okay, right. Okay, you can put a graph, right? So first discretize the interval that you are interested in, right? And here I'm interested in minus pi plus pi. I want to discretize that using 50 points, right? And your dependent function, then you calculate the sign of each point. So you compute the sign value of each point, right? Then you can plot that x and y using this command plotting tool. Now, yep. Let me. So if you want to add a label, how do you do that? So you remember you did these things last year, right? X label you can define here. Give a name. Let's say this is your x-axis. You can give any name, right? You can so put a semicolon, right? Okay, and can label y-axis as well. Y label. I will give sine of x, and you can give a title, right? You know these things, right? I don't remember title. I think title. Yeah, title inside the quotation mark. I'm not sure, single quotation, right? So you can give a title as a sine of x, graph of plot of something like you can grid on. You can see the grids. So grid on. Let's see. All right, we have x. What is there? This column, I'm not sure. Difficult to pinpoint there. I think you can handle this one, right? Still, we are getting that one. Yeah, you know how to do that. Yeah, the title. I'm not sure. Let's see. Can see the letters, right? Still, we are getting title. Yeah, something is missing here. I think I don't know. See. So you can do that. Yeah. What's that? Dijon, can you spot the error? I'm not sure whether.
No, so I can't find out there.
All right, then I'm not sure whether we All right, you can handle this one, I think, right? Just type the help. X label X. Yeah, how do you do that? Yeah, you can handle this one because you have experience. Yep, this is how you plot a graph, right? Grid on. I think this is the one. I think. Yeah, this is the mistake. I think. Ah, yeah, we are getting. All right. Yes. Let's close this one. Anyway, all right, you can do this one. Yep, I'm the expert on this. All right. Yeah, what is this? Yeah. All right. Oh, that is, yep. Okay, then let's go to a small activity, right? Day one. Take example. So can you read this one? Can you do this example? Yeah. So we did this one yesterday as well. Yesterday or day before yesterday. Yeah. All right, you can download this one from your LMS. So is this FM? Yeah, FM. Yeah, yeah, this one here. Yeah, I will share this one. The second. Share this document. Yeah. All right, read this out. So consider the following difference equation model for the percent of a drug that is administered once per hour. Yeah, time is in hours. Yep. So let's say you are getting shot. You are getting a shot in 1 hour. Every hour you are getting a shot. All right. So we measure the amount of drug in your bloodstream. AT is the amount. So this is a difference equation, right? So look at, let's see the degree. This is a first order. Yep. So T plus 1 is equal to AT. What is AT? AT is A sub T is the amount of drug you will get a drug, right? All right. So every hour you will get this drug, right? Then we count the amount. We want to know the amount of this drug in the bloodstream. Every hour you are getting this drug, right? All right. Initially at time t, there is no drug. There is no drug in your bloodstream, right? At the beginning, right? After 1 hour, you have some amount of drug in your bloodstream. So you keep getting that drug. Now we measure the amount of drug in your bloodstream. So this is the relation, right? So AT plus 1 is equal to this one here. So why you are getting negative here, let's read this out, is So 80 is the amount of drug in the bloodstream at time t. Okay. So D is the dosage. All right. D is the dosage. Maximize this. Okay. D is the dosage. And the constant 0.1 here reflects the fact that 10% of the drug lost through the filtration by the liver per hour. Okay, your liver filters this drug. 10% of drug. Yeah, you will lose 10% of this drug because of your liver, right? Every hour the liver filters 10% of this drug. Okay. So what does the model tell us about the initial amount A sub C of the drug in the bloodstream? There is no drug in at the beginning, yeah, right? There is no drug at the beginning. So now you start the process. Yeah. So this one here. Now you take the drug. You take a drug. So at this point there is no amount in the bloodstream, right? So after 1 hour, you will take another drug. You will take a drug, right? You measure this one. Now you can see some amount of drug in the bloodstream, in your blood. And again, you take this drug after 1 hour. Then this is the amount after 2 hours. This is the amount of drug after 2 hours. And again, you will take this drug and you measure the amount of drug in the bloodstream. Something like that, right? You keep taking that drug and you measure the amount of drug in your blood. That's the thing. Yeah. So that explains this in this difference equation, right? All right. So use the solution by trade. Yep, you can compute A1 because you know A naught. A naught, you know the initial amount of drug in your bloodstream, right? So then you plug this value into here. That means when you plug the value of t here, let's sub t equals 0, right? Into here, if you throw that one, you can find a sub 1 and so on, right? If you know a sub 1, then you can find a sub 2. Like that, you can compute by hand, right? All right, you can compute. So, but the answer, so you get an answer in terms of D. D is a dosage is a parameter here. Suppose, right? Let's suppose your dosage is this much, right? 0.01, right? Okay, so this one get rid of. All right. So this is the mathematical model, right? So now we are going to use Octave to compute this pair. Which pair? At 0, we know A sub 0 is 0. We already know that. After 1 hour, that means t equal to 1. a sub 1. We have to compute that by throwing numbers, just subbing numbers. We can find a sub 1, right? So you know how to do that, right? So, and a2, a3, and so on. So we want to plot these points. Can you do that for me? Yep, I will help you. I will help you to do that using matrices, for loops, right? Because you have experience to do these kind of things. Last year you did these type of solve these type of difference equation or differential equations, right? So you have some experience to handle this problem. Let's do this one, right? Okay, so here look at this one here, right? So you can find a close form of this difference equation. So how do you see here? So it turns out that this difference equation has a closed form solution given by this formula, right? That means, so here initially you have this one here, a sub 0 is 0. If you throw t equals 0 here, what do you get? 10 times d times 1 minus 0.1 to the power 0. That means this becomes 0. Then g of 0 is 0. All right. That means, g of 0. If you don't know the difference equations, same with a of 0. If you compute g of 1, right, you will get a of a sub 1 and so on, right? G of 100 would be the same with a sub 100. That is the close form. So use this one to find all AIs, ATs or something, right? This is the closed form of, let's clear this out. All right. So this is the closed form of this difference equation, right? And take the value of, let's assume the value of d is this one. And I want you to plot these pairs, 100, let's plot the first 100 pairs. Can you do that for me? I want to see the first 100 pairs. Can you write a program using Octave? This is your t-axis and this is your a sub t. So these are pairs t comma a sub t, t comma a sub t, right? So let's use, all right. So, okay guys, I need your feedback. I want your feedback. So can you handle this one? Because you know very well, right? Let's clear this out. Yep. All right, let's let me. Yep, you can do You can write a program for that. The font size, I want to change the font size. Command font editor. Okay. All right, let's do that. Right. All right. Yep. I think you can manage to do that, right? Let's revise this. All right. Let's try to use our knowledge on Octave to do this problem, right? All right, close. When you start a program, all the time you clear the memory, you clear all memory, clear all variables, all memory. Yep. So how do you do that? Clear all, and you close all windows, close all, yep, and clear the screen. CLC. Okay. Clear memory, close all windows, and clear my screen. Yeah. And let's define constant terms. What are the constant terms? So this is the independent variable. T is the independent variable is a sub t. So starts from 0. T goes from 0 to 100. Okay. Or 100 or any number, right? So let's define those variables. Yep. Let's initialize those variables. T equals 0, and we have a value for d. What is the value of d? D is 0.01. Okay, let's enter that one as well. Okay, constants. And what else? What else? T depends on this dependent function, g of t or anything a. You can use a of t or something, because this is a closed form. G of t is same with a of t, a sub t, right? So I will use a, right? I initialize this one to 0 because initially we had 0 amount of drug, right? At time 0 we had this much amount, this 0 amount of drug, right, in the bloodstream, right? All right. So now I want to compute this pair, let's say 100 times, right? That means 0, a sub 0, 1, then definitely you have to include a for loop, right? A for loop. Let's use a variable, any variable, let's say t, we use t, all right, let's say k. K goes from, I will say 1 to 100, right? So this is your for loop and you end this loop. Okay. 20, right. So this is the body part. I think you know these things, right? You are expert on this. Yep. All right. Now before that, I will put these two data into a matrix. I'm dealing with matrix. If you deal with matrix, then it would be easy, right? I put the independent variable and dependent variable into this matrix. So first column has it has the independent variable t, the value of here the value. So the value of t is 0. Initially you have 0 here, and this is your dependent variable, the corresponding value, the amount at time 0, the amount of drug at time 0 is a, yeah, which is 0, which is 0 as well. Okay, I initialize this matrix and I extend this matrix below. I extend this matrix row wise. I put all data. So this is my first row. I extend this one like this. Then I can easily plot the graph, right? It's time 9:50 up. 8:50. All right. Okay, then. All right. So what is the relation? All right. This is your A sub t, or G of t, or these are the. This is the amount of drug in the bloodstream at after t hours. All right, let's enter this formula, right, after t hours. Now what is that? The amount should be equal to 10 d. D is this dv initiate. Yep, 10 d times 1 minus 10 d times 1 minus 0.9 to the power t, right? To the power t, yeah. To the power t. So I don't see the output. Then I will enter semicolon at the end. All right, this is my amount after. This is the amount of drug after t hours, right? You can comment if you want, right? Amount of drug after t hours. Now I put this data into this matrix. All right, let's do that. Okay, I will update that matrix or extend my matrix. Initially it had one column and two rows. Now I am adding 100 columns, 100 rows. All right, let's do that. Okay, I will update my matrix M. All right, take this row, take this one, right? Right, take this one. When k is equal to 1, right, then the computer computes the value of a sub 1, right? Then I want to include that one to this matrix. All right, so this is the first row, 0 0, right? Here 0 0, right? and put another and include another row. Then I have to break this break the row and include the time. Time is now k is 1, right? K and the value, the corresponding value of a, the corresponding value at this time. That means the amount of blood, amount of drug in the bloodstream. Yeah, A. All right. So there are different ways to do this. I will use matrices to compute, because when you use matrices, the computation part is pretty easy, right? You don't need to worry about many things. Just you are just playing with matrices. That's it, right? That's why you learn matrices last semester. Let's use those things, those concepts. So when you write these kind of codes, right? All the time, try to use matrices as much as possible, right? It's possible, right? All right. Yes. Close this one. I don't want to see the output. Then I add a semicolon at the end. All right. Let's try to understand this. Okay. When k is equal to 1 and we have a sub 1. And here, initially we have 0, 0 here. These values are 0. Then 0, 0 and break that row then and put k value. Now k value is 1 and the corresponding a value is this one. Something like this, right? So let me draw. Yeah, initially this is your m. Initially you had 0, 0. Now when k is equal to 1, you compute the corresponding a sub 1. This is a sub 1. All right, then the value of k, that means time 1, and the corresponding amount a sub 1, I will say a sub 1. Then at the next turn, right, when k is equal to 2, again you compute a sub 2, right, a sub 2. Then take the previous m. Now you have 2 rows. Take the previous m and add the additional row, this one. Now k is 2 and the corresponding value is a sub 2 and something like this, right? And next turn 3, a3 and so on. Hope you understand, because you're expert, right? You are expert, not like me. Okay. All right. All right. Now let's. Or if you want, we can see. And let's see whether this is run. Code is running. Yeah, all right. Perfectly. Oh my God! Not. Yeah. Why is that? It's not taking. Yeah. Why is that? What's the problem? So should be k in. Yeah. Yeah. Have to include k this time. Yeah. Thank you very much. Yeah. All right. Okay, here we go. The time is 0, the amount is 0. After 1 hour, you have this much in the bloodstream. Yeah, stream. After 2 hours, you have this amount of drug and so on. All right, now we have to plot. this one, this matrix. That's it. This is your independent variable, discretization of independent variable. This is the dependent. All right, let's plot this. Okay, plotting part. Plot. All right. I want to get the set of independent, the data point of independent variable x. That means m take. I want to read the first column of this matrix M. All right, first column. That is your independent points. Those are independent points, right? Independent data, variable data, and this is the dependent. I want to read the second row, second column of M. All right, that's M, the second column. All right. If you want, let's run this. Okay, I want to see it in dots or dots. I will change the style. How do you change the style? Yeah, let's change the style. Courses or dot. See. Let's see whether it is changed. Yeah. What is the style? Yeah. Don't know how to use this asterisk more. Style. I don't know. I'm getting this weird notation. I'm not sure whether. I think I'm. How do you do this? Let's give a space. Let's then this mark inside this. I will type O. Yeah, what's this? I want to find this out. Yeah, what is the error of this? Yep. So try no, instead. All right, I will try. Thank you. Yep. I will try this instead of using. I will try double quotation inside of. See whether this is working. All right, thank you very much. Yep, it's working very well. Yep. So I have to use double quotation mark. Yep. All right. So if you, earlier that was the problem. Yep. Then you can add the legend or X. You can label these axes, right? X-axis and Y-axis. And you can give a title, right? And I want to make sure that I'm using, this double quotation mark. That's good. Yep, thank you very much. Thank you. That's why I told you are better than me. Yep. All right. Okay, I hope you understood this one. Now it's time to do this activity with our great teachers, Deshani and Tutika. They know very well better than me, right? So they will help you to do this activity. So do the first activity with first problem with them, and the second problem you can do it on your own. Yeah, this one. So this will refresh your memory on Octave. So this is a warm-up class, right? Next week onwards, you are getting assignments or mini projects. So you have to complete those projects and upload to LMS. Then we will correct your assignments and you will receive grades or scores based on your performance, right? So this is a warm-up class, right? And just try to understand, try to yeah, to remember these things. You have to refresh your memory on these things, basic stuff. Otherwise, cannot move forward. All right. Do the first question. Yep. With our great teachers, Pubutika and Deshani. They will help you out. If you have any questions, so you can ask them. They are happy to help you. And the second question, you can do it on your own, right? So basically, you are plotting a graph. Yep. Try to do the first part. Yep. Yes, Deshani, the mic is yours now. Deshani and Pubudika. So I will change. All right. Oh, how are you, Pubudika? How are you, Deshani? Doing well.
Yes.
All right, keeping safe. Yep. All right. Right, start working on this activity. Yep, it's time to play with octave or play with matrices. All the time try to use matrices as much as you can, right? Include matrices. If you include matrices, and pretty easy to do the job, right? Yep. All right, so, okay, yeah. Let's read this out. You are all the steps you need to follow. You should always add your own mini footnotes to the core as you write. Start a new file and Octave. At the top of the file, define the constant. You have to define these constants and make sure that when you start writing a script, make sure that you include this in clear memory, close windows, and clear your screen. And then you can define your constants like this. Yeah. So here you have how many? 1, 2, 3 gravity. So what is this? Yeah. So yeah, do this one. Okay. Yep. Bhuvdika, you can share your screen, I think. All right.
Sir, should we give them more time to try it?
Sure,
Or
sure. Yeah, definitely. Yep.
Okay.
Right. All right.
We'll give you about like 10 more minutes to try this out. Then we'll start explaining the code. If you encounter any problems, you can ask.